In section 3.3, we're going to look more explicitly at domain and range of functions. If you remember from earlier from the first section, we talked about this a little bit, but domain was the input, or what you do to the function. So I like to think of domain as the do, which since that's the first two letters, and then the output is also referred to as the range. Range is what you get from the function. So it's an easy way to remember that if you take the last two letters of range and maybe add a t to it. It's what you do and what you get. It's the input and the output. So when they ask us for what is the domain and range of the following function given by the set of points, the domain are all the inputs, which are the first values in the ordered pairs. So we just need to make a list of those in ascending order. So the smallest I see up here is -7, and then we have -5, and let's see, the next smallest number is 2. We have two 2's, but it's okay because it's still a function. We put in 2, we got a 6. We put in 2, we got a 6. No need to list it twice. And the last number we also put in as a 3, so that would represent the domain of the function. The range of the function would be all the outputs, again in ascending order. So if I find the smallest output, I have 6, 1, 3, 6, and 5, so it looks like 1. We use that output right there, and the next highest after that is 3, and the next highest after that is 5, and finally the last is 6. You don't need to list it twice. You only have to list it once when you're putting the range down. So on each one of these, domain is what you're allowed to put into the function or get. The domain's the input and the range is the output. So if you look at the next one, it says given f of x equals 1/2 of x plus 6, and its domain is described by the set of -6, 6, -8, 4, and 2. What is the range? All right, so they're specifically telling us they're only going to allow the domain to be those 4 numbers, meaning the input. So to find the range, I'll have to plug in each one of those values to figure out what output each one has. All right, so let's start by plugging in 6 first. So first we'll have 1/2 of 6 plus 6. So half of 6 is 3, and 3 plus 6 is equal to 9. So 9 is an element of the range. Alright, the next point we'll plug in is -8. So that's equal to 1/2 times -8 plus 6. So half of -8 is -4 plus 6. That's still going to be equal to 2. Again, you can use your calculator if you need a little assistance, but f of the next one, I'm sorry, f of 4 is equal to half of 4 plus 6. So half of 4 is 2, and 2 plus 6 is equal to 8. And then next we have f of 2, which is equal to half of 2 plus 6. So half of 2 is 1, and 1 plus 6 is 7. So we need to evaluate all those. If we're going to limit the domain to just that, then the range would just be all the possible outputs that were given from those inputs. So the range, again, I'm supposed to put this in ascending order, would be 2, 7, 8, and 9. Alright, so this is kind of in reverse. It says given f of x is equal to 2x minus 1, and its range is described by the set 5, -3, 1, 9. What is the domain? Alright, so this is in reverse. So they're telling us the output first. We know that basically we have 2x minus 1 equal to 5 for the first one. So you see what I'm saying? I'm going to figure out what x needed to be for that 5 to be an output. So to do that, we just need to do some algebra and solve this. So we'll start by adding 1 to both sides. And so we'll get 2x equals 6. And then we'll divide both sides by the coefficient 2. So one element of the domain is x equals 3. Let's try that again with the next element of the range. So again, we want 2x minus 1 this time to be equal to -3. Again, we just go through and carefully solve for that. So you can do that by adding 1 to both sides first, which would leave us with 2x equals -2. And then divide both sides by 2. And we find that for the domain we have x equals -1. Alright, Alright, for the next one we need to figure out how to have 2x minus 1 be equal to 1, the next element of the range. So again, we just go through and solve this by adding 1 to both sides first. So that's 2x equals 2. And then divide both sides by 2. And for this one we get x equals 1. Alright, one more element of the range we got to contend with. So we got 2x minus 1 again is equal to 9. And again, to solve that we'll just need to add 1 to both sides first. So that'll leave us with 2x, the ones cross out, equal 10. And then divide both sides by 2 again. And for this one, x had to be equal to 5. So the domain for this one is equal to, let's see, negative 1, 1, 3, and 5. I just put them in ascending order. Now let's try some other visuals here. Now the next they're asking us to find the domain and the range of functions. So I think this time it might actually be helpful if I showed you a visual that I created in PowerPoint. Let's see if we can look at this together. Okay, so on this one we're looking for the domain of this function. It goes pretty much forever. It goes down, but it goes to the left. It's moving down and left, and it's moving down really fast, but it's still moving to the left and it's still moving to the right. Domain is all about basically how far left and right the graph moves. And in this case, this graph appears to go forever to the right and forever to the left, so it would be all real numbers. So since the domain goes in both directions forever, they'd say it's a set of all real numbers, which is a weird looking double bar R, or sometimes you could say negative infinity to infinity. Let's look at the range. The range is all about the up and down values, the y values. So in this case I want to kind of figure out, it does top out somewhere right about here. So it's the range are only values from basically about 8.6 and down. So the way we could say this is when y is less than 8.6, so it's everything up and down when we're doing range. Let's try it again with another function. Alright, so in this one we're looking again left and right for domain. It's about the x's. So if we look left and right, basically it starts at negative 3 and goes forever to the right. And so mathematically you could say that x is greater than or equal to negative 3 because the domain continues forever to the right. Those are the possible values of x. For the range we're talking about up and down, so the highest or the lowest this graph ever reaches. So the highest it ever reaches is 4, and it also reaches everything below that because it goes down forever. So we'd basically say for the range of this that y is less than or equal to negative 4, or you could also say negative infinity to 4, and we'll practice that some more in some of the other problems that we're going to try. Move this back up to where. Okay, so on this graph, let's see if we can do the same thing. It moves forever left and forever right. So domain is all about your left and right. And in this example, since it moves forever to the left and forever to the right, we could just say all reals for the domain of this. So all reals, which if we wrote that in set notation, we use a double bar R, and I think that's good enough for now. And then if we look at the y values, that's up and down. So what's the lowest this graph ever reaches and the highest this graph ever reaches? All right, so the lowest it ever reaches is negative 3, and it goes up forever. So in this case we'd say that y is greater than or equal to negative 3. Now there are some other ways we can say these. Let me see if I make this a little bit bigger. I can also use what's called interval notation. And interval notation is just a different way of saying the same thing. That right there is set notation. Interval notation, you're basically saying from negative 3 and up. And mathematically that would be equivalent to writing it like this. In interval notation we could write negative 3 to infinity. That means everything from negative 3 and above. All reals, if you want to write that in set notation, you'd write basically everything from negative infinity to positive infinity as part of the answer, if you want to write that in interval notation. Alright, let's look at, again, the domain. Domain is all about left and right. I should have put that note over here. So domain is left to right, and range is all about how far down and up it goes. I could say up and down, but usually you start with the down. Alright, so again we're going to try left and right on this one. This function moves forever to the left and forever to the right. So again, the domain of this one is all reals. mean any real number at all you can have on that graph for x. But the range is limited. If you look at this function has an asymptote at 1, so again, range is up and down. So it bottoms out at 1 and goes up forever. So the way we'd say this is y is everything bigger than 1. Now, I didn't include the equal sign this time because that asymptote is an imaginary line that the function gets closer and closer to but never touches. So it's not really equal to in this case, whereas this one we said it did actually make it to -3. Alright, let's try on this one again. Now the domain on this one is broken up. It basically, if you look at left and right on this one, it does go -2 and forever to the left, and then there's a gap, and it goes 3 and forever to the right. So if I were going to write the domain in set notation on this one, it would look something like this. I would say that x is less than -2, because right there left, and I could also say or x is to the right of 0. And now look at this carefully too. I used an equal sign for this one because it had a closed dot, and I used a no underline for this one because it had an open dot. That's, again, it's talking about left and right. So if I wrote this in interval notation, another correct way of writing this would have been -infinity to -2, and then over here I would have written from 0 to infinity. So it's the same thing, just this is interval notation, this is set notation. Interval notation has you list from left to right where it happens from. So this is from -infinity to -2, and this one goes from 0 to forever. So if you look at this too, I used different brackets here. I used a circle bracket when it was open, no equal sign, and I use a square bracket when it's a closed dot. Alright, let's see if we can figure out the range of this. The range is the up and down portion. So the highest this graph ever reaches is 3, and honestly it keeps on coming down for forever. And although this comes down forever from -2, this graph already covers everything coming down, because the highest it ever reaches is 3, and it's everything below that. So here we would say y is less than or equal to 3, so it's saying below 3. In interval notation, that would be basically, from -infinity to 3. You'd have to say the lowest is -infinity and the highest is 3, and I'd use a square bracket. But set notation is okay for right now. Let's continue trying these graphs. Now, this is an interesting one. So again, think about left and right for domain. So how far left and how far right the graph goes is all about the x. Alright, so if I go all the way, this one goes forever left and forever right, so this is all reals. Anytime it covers everything, it's all reals. And think about this, the range is the up and down, or I should say down and up, because you start with the down and go to up. So how far down does this function reach? It goes down forever and it goes up forever. So once again on this one, this is also all reals. Alright, let's continue on the next one. Alright, so in this next middle function, that's a square root function. It goes basically left and right is what we're talking about first, but the furthest left it ever makes it is -2, and then it goes forever to the right based on what the arrow suggests. So in this one you'd write x is bigger than or equal to -2. It kind of even makes an arrow that points to the right of that. We're going to the right of -2. The range is up and down, so it looks like even though it's moving to the right, it's still continuing to move up forever. But it doesn't, the lowest it ever makes it, if I go down and up right here, is 1. So on this one we'd say when y is bigger than or equal to 1 if I look at the y values, because it's up and down. Again, you could list either one of these in set notation, or in interval notation, since I just gave set notation. So interval notation would look something like this. Again, just for practice, set notation is fine for now. We're saying basically x starts at -2 and goes up, and so we would start at -2 and go up, and the y would start at 1 and go up. Both of these mean the same thing. So on the left we'd call that set notation, and on the right we'd call that interval notation. They both say the same thing. Alright, the next one has an interesting way of, there's a couple ways we can write this. The domain is all about left and right, so it has two asymptotes right here. It has one at x equals 3 and y equals 2. It goes forever left and forever right, but there is a gap right here in the middle that it can never be. So there's two ways we could go about writing this. One way is we could do it like the classic way. We could basically say that x is strictly less than 3 or x is greater than 3. That's completely correct. You're saying left of 3 and right of 3, but just not 3. A shorter way would also be to say just x can't equal 3. That means everything but 3. So both of those are correct. The range has the same problem. It's everything above 2 and below 2. It just can't be 2. So you could get away with saying y is less than 2 or y is greater than 2, or you could simply just say y can't be 2. That means it can be anything but 2. So either of those are correct. Now in interval notation, I'm going to erase this, it might get a little messy, but you'd actually write negative infinity to 2 and then use a bracket and then use union 2 to infinity. And basically that's saying from negative infinity up to 2, hop over 2, and then go from 2 to infinity. And you could do the same if you really wanted to list the domain as that as well. Let me stop here and start the next page. Please ask your teacher if you need any additional help with this.